Okay, students, this video I'm continuing 4.3 and 4.4 practice problem on logarithmic functions. So let me begin. How do we use the calculator to figure out this? Now, what is this? What does the logarithm of 60 basically means? And it does not show any base here. What basically means? This is a spatial logarithm with the base 10. That is because when you for the exponential function, let's say y is 10 raised to x. So the inverse of this is taken logarithm of x to the base 2 10. So when and so yeah, so Neperian logarithm. So let's see how do we figure solve or how do we find using the calculator. So let me go straight to directly to the Nspire calculator. So let me directly go a new one and okay, so here you click on the calculator and then here there is a log. You can see log. If you want to use logarithm, the base 10 there's already a control and you click there's a log, but still you have to put 10 there even though it did not show. And you want to put 7 and you see just put control and enter and you get the answer, but you need to put it in 4-place decimal. So this 9 could be because this 9 is more than 5, 5 or more than, so this 0 could be increased by 1. So that's all you're supposed to do, not difficult. But if I want to go back the same thing and enter, and I want to, maybe someday they may ask you square root. So all you do is take this up and put the square root. There's the square root right here. Control this and put 69 maybe and just enter and you get. But if you just directly enter, then it won't give you the answer. So all you do is go back and enter. And this time you click on control and enter to get the answer. So hope that works. Let's go back to another problem. So this is problem number 5. So gx. So how does this graph of gx? We already seen this in the very first problem of how the graph will look like. And you can see in this is an example where when the base is 2 or 3 and 5, the higher the base, so the bigger the base here, the graph is like almost like and there is a kind of compresses, or I will say flattens here. So the graph flattens when the base become bigger. That's because the exponential function, let's see, if this is 2, if I try to draw y equals x and the red one is here, so this graph is something like this. But then the black one, you see the black one is logarithm of 3. So that will be a little steeper. So that's how this one will be. And the blue one, this one, it will be more steeper. See, it will be more steeper like this. And then the purple one, I don't have a purple one. I'll have to get the purple one. So where is the purple? Oh, there you go. So this purple, which is almost like closer to the x-axis, so this will go something like this. So the idea is how the question is, what is this graph look like? And remember, one more thing we're already showing here. This is e raised to x. So when you talk about e is 2.718281, and it's an irrational number. So which is a natural number also. We call it natural number. So if the inverse function is logarithm of x to the base e, and in short it is written as ln of x. That's it. It means it is the base is e. That's all it is. Now, and you can see the graph is like this. And then if you say you want to check e raised to x is between this is 2 raised to x and this is 3 raised to x, and e is this one. So I can use any color that I do not use. I think all the color I use. Maybe I'll use this green color. So the green color, this is like a graph of exponential function e raised to x. So that way, this will move this side. So this is how it will go. through this and like this. So that will be logarithm of x to the base. I hope this makes sense to you guys, what you've been learned in already algebra 2 and pre-calculus. Let's go directly to what the question is. So the question asked is how do we graph this? This part, okay? Now, first of all, we want to know that we need to know what is the logarithm of x, just an x to the base 5. Now 5 will mean, that means you can see this is 10, and there's a 5 there. The blue color is showing you 5. That's the 5. So if this is 5, how will it be? And you can see from here what changes is x is replaced by minus x. And from we have seen the transposition of function where if there is a fx, and what is the g of if a new function g is f of minus x. It's the reflection over the x-axis. That means if this is the graph right here, so it will reflect, let's say this is minus 1 here. So this will be here and it will go like this. So if it is this one, which is 5, this will go something like this. So that will be the graph. And you can see there's a vertical asymptote. So you will see this is a vertical asymptote. So vertical asymptote stays the same. That is x equals 0, which is the y-axis, because you can see it's coming almost closer to the y-axis. So the main thing, what's the domain of this? So the question, what is the domain? So the domain is you can see from the graph itself, it goes this side to the left. It means it goes this side. So as x goes very large negative number, and this goes to plus infinity. So that means the y value, that means what is the logarithm of 5 to the minus x? This goes to plus infinity. So all you're supposed to write here is the range is, so the range is, okay, sorry. So first of all, the domain is negative infinity all the way to 0, and the range is, it the graph goes down, this goes all the way down, this goes all the way down to minus infinity, and then it goes up. That means it goes, of course it goes this way, but eventually it goes to plus infinity. So that's why we say the range becomes negative infinity plus this. So I hope this makes sense to understand that the graph that was here. So this was the y equals logarithmic of x to the base 5, but now it reflects, and see the domain changes. And basically, what is the domain basically means? You can see the input here is minus x. This has to be positive. You can't have a negative logarithm. And when you divide by minus 1, algebraically you can see it is less than minus, less than 0. And you can see that works here. So we will do one more of this and maybe we can understand that. Now, how do we graph this one? Remember, if I draw x-axis and y-axis, we have seen the graph of the logarithm. If it is just a logarithm of x to the base 5, so that means it goes through 1. So that's the graph is like this. So let's say this is logarithm of x to the base 5, and then and this side it goes down almost to minus infinity. See, so the range is from minus infinity all the way to plus infinity, and the domain is this part. It doesn't take 0, and then all the way to plus infinity. So that's the domain part. And the vertical, the black, the y-axis is the vertical asymptote. So here x equals to, so for the logarithmic function, so the so the y-axis itself is the vertical asymptote. So I hope I'm making sense to you. The reason is when x becomes very large, a positive value, you can see logarithm. It means the y, which is logarithm of x to the base 5, and this will be almost going to infinity, very large number. That's all that means. Now the question is, what does the other part says? Let me take the arrows I don't want and put number. This is like a 1, and why it is 1? Because the logarithm of 1 is 0. And why it is 0? Because if you push this, it is 5 raised to 0 is 1. So question is, what is this, right? And you can see we have seen from previous that whenever you x minus 4, that means the graph shifts. So this means the graph shifts 4 places to the right. 4 places to the right. So that means if this is the point, and there is a 2, there is a 3, there is a 4, there is a 5, it has to move 2 places to the right. That means this dot will go 1, 2, 3, and 4. So this will go here. And then this dotted line, see this vertical axis, this will move 1, 2, 3, and 4. So this will go right here. And the graph will look like, using the purple color. So that means I don't have enough room to move that. Okay. So this whole thing will go something like this. See? Start from down and it will go something like that. So this is going to be the graph of this graph which goes down. So the range stays the same from minus infinity plus infinity, but the domain changes. So what is the domain is? So it starts from not 4. You can't take 4. See? So it is x. It starts from 4 and goes all the way to infinity. That's the domain. And the range is the same as I said. The range does not change. And what is the vertical here? The vertical asymptote is this is the 4. So this was the original vertical asymptote. Now it has moved right here. So that means you can't have, what is the meaning of that? Is x equals 4 is the vertical asymptote. Why? Because you can't plug in 4 over here. If you plug in over here, x here, this will be logarithm of 4 minus 4, 5, and that will be 4 minus 4 is logarithm of 0. So you can't have input as 0 because that's how the definition, log is defined only for x greater than 0. So I hope I made sense and we got the clear that, okay, the let me finalize this. The red one was the original graph of logarithm of x to the base 5, and it had a vertical asymptote, this one, which is x equals to 0, and because of this minus 4, the original graph shifts 4 units to the right. That's how. So I hope that makes sense, and the domain changes accordingly because it is going to the right, and you're done. So this is that's problem number 7. Let's see. So this time, I just assume that we don't know even sometimes they give you the original graph and I'll just see, okay, first I want you to look at this part. Instead of plus 3, I'll put it on the right side, logarithm of x to the base 2 and then plus 3. The main thing is the first part. What is this, right? And then there's plus 3. That means this is like positive. Means graph graph shift 3 places up. That means all I have to do is so let's graph the original function first, the 3x. So how does the 3x, now this 3 is smaller than 4, 5, 6. Remember the graph, the the bigger the base is, the flattens, but 3 is quite little smaller one. So if this is 1, it may be something like this. So this is the graph. But because I need to show, I'll try to change this and make it little. Oh, sorry, let me clean this one. Okay, and maybe this is, and the original graph is something like this. Maybe- So this is the original log, let's see, logarithm of x to the base 3. And you can see this graph again, you can see the vertical asymptote is this line, the original one. But now this graph shifts 3 units up. So all you do is just this one, this is 1, 2, and 3, and 4. That means this goes 1, 2, 3. So this point moves here. That's it. Every point moves one. It's like if there's a point here, it will 1, 2, and 3. So it goes, everything moves up. So that means this graph will be something like this. That's all it is. So the vertical asymptote will stay the same for this part because there is just an x. So the vertical asymptote will be x equals 0, which is the y-axis. The y-axis, the equation is x equal to 0. And then also the domain. Now the original function, the domain is 0 to plus infinity, and that also stays because you can see this one. This was the original domain here from 0 to plus infinity, and because it is not shifting to the left or the right, so the domain stays the same. So this stays the same. And even when you move the graph, the blue graph has become the red graph. So it goes to plus infinity up, and then it goes to plus infinity down. So the logarithmic function, one thing you need to know is the range does, of course, you have to be very careful also. But in this case, the range never changes. Whatever the original graph is, it will always remain the same. Okay. Now look at this problem number 8. It's just asking you what is the domain of the function. So what is the domain? Remember in order to know the domain of the function, it has to be the parenthesis. This whole thing, log of this has to be greater than 0. So all you do is subtract this when you get x is greater than 5. That means on the line, let's say if this is the case, that means if you only want to graph the logarithm of x to the base 5, then the graph will be this one. This will be the graph. But then because there's a plus 5, look at this plus 5, and it means that the parent graph, this graph shift 5 units to the left, 5 units left. And you can see algebraically it's the same thing. It has to be greater than minus 5, means 1, 2, 3, 4, and 5. That means this graph. So 1, 2, 3, 4, 5. It means this dot goes 1, 2, 3, 4, and 5. So there it goes. See? So at 4, so the x-intercept here was 1, comma 0. Now it becomes negative 4, comma 0. This point is negative 5. So if this is the vertical asymptote, then now there will be a new vertical asymptote, and that will be this one. So the y-axis, so this y-axis, which was x equals to 0, now it becomes, oh sorry, I made a mistake, not here, it should be at minus 5. So yeah. So the graph, this is the vertical asymptote, which is x equals minus 5. Remember, the domain is greater than, the domain has to be greater than my negative. So this domain, so what this means, you can't have minus 5. It means from minus 5 all the way to plus infinity. So all this becomes the new domain for the function, this function. Okay, too much of things are going on here. So the domain is, so how do we write? Okay, the new domain is negative 5 till plus infinity. But the range is, as I said, range always stay the same. It does not change. It goes down and up. So that means the new graph would be, so the new graph will be this one. this graph shifts here, right? So this will be the graph, something like, and then it goes down this way. So it goes down like this. You're done. That's all it is. So what are you trying to understand is that the original graph, which is logarithmic of x to the base, shift 5 units to the right, and by doing so, the domain changes to this. The range stays the same, and the vertical asymptote, which is x equals to 5, now become x equals to -5. That's all it is. Ha ha ha. That's it. So this another problem, I would say, like problem number 9. Consider the following. So you're given two functions, and the two functions is one is a log, and the other one is algebraic linear. And you're supposed to find what is the, let's say, composition of the two functions. Now remember, when you talk about this, it means x is greater than 0. It means the domain is 0 to infinity. But for this one, the domain is minus. You can plug in anything. Okay. Okay, and the range is also minus infinity to plus infinity. But for the logarithm function, the f of x, the range is from minus infinity to plus infinity. So few things to be taken note of. But then if I want to find what is, first part is, what is, suppose they ask a question, what is f of f circle g of x? Create a new function. What is the domain? So by definition of composition of function, this is f of g of x. And then what is g of x? Replace g of x, which is x minus, put it here, right here, it is the x minus 6. So for the input, for the function f, the input is x minus 6. This becomes the input. But the input, when you talk about f of x is logarithm log of the input. So in this case, all you do is you write the logarithm, and x, this will go right here. So x is replaced by x minus 6. So this becomes x minus 6 to the base 2. And the question is, you can't have, and if you look at this, the composition function, this one now is this. So this part is this one. I'm going to write it again: logarithm of x minus 6 and 6. But the thing is, you can't have this input greater as 0. I mean, so it has to be greater than 0. So, so all you do is put x minus 6 is greater than 0 and put plus 6, and there you go, and you're done. That means the domain now will be, for the new function f circle g, will be greater than 6. Anything greater than 6, that means 6 is the lowest you can go, but you can't take 6. That's, so everything 6 and till until infinity, that becomes the domain. So your two answers would be, one is this, but the domain is this. So be careful with that. But what about G circle F? So if we need to figure out what is G circle F, composition of this, so this will be G of f of x. But the f of x is, will go right here. That will be G of logarithm of x to the base 6. And then what does G do? Give any input to it, it just takes away a 6 from whatever the input. So this input you just take away. That means right now the input here is logarithm of 6. This is the input which you are plugging here. In place of big X, you just plug that. So your answer will be here. This is the X. So the red one, this is what it will be replaced now, this X. So this will be, so this will be minus 6, whatever that minus 6 right here, but the red one would be logarithm of x to the base 6. And clearly that's the answer. But what is the domain? And you can see here x has to be greater than 0 because you can't have a negative there. And you just write greater than 0 means if this is 0, everything to the right of 0, that means 0 to plus infinity, and you're done. Now in this question, question number 10, the question number 10 says, find the domain, and not only domain, they're also asking you more questions. Let's say you need to know everything about what is the x-intercept, right? So this is first question. What is the domain, maybe? And then also, what is the vertical? These are the main thing, vertical asymptote. And you also have to know what is the range part. Okay, and how the graph, and then the sketch. So these are the main thing you need to know. Now, if this is given to you, the first thing is you want to know the x-intercept. Always remember, x-intercept is where, if this is 1, because logarithm of 1, whatever the base is 0. That means it is 1 comma 0. That means we need to know when is this going to be 0. So first part is to do this is you put x over 6 is 0. And if you multiply 6 both sides, you can see x equal to 0. That's the x-intercept. So your x-intercept becomes 6 comma 0 is the x-intercept. Second is what is the domain? The domain is the inside the parenthesis should be always greater than 0. So that's how you start. But then it goes back to x greater than 0. That means everything more than 0 means 0, and then everything higher, so it becomes plus infinity. That becomes the domain. To find the vertical asymptote is very easy. Whatever this part is greater than 0 means, you just put a equal sign. That becomes the vertical asymptote. And the range is always, because the logarithm is minus infinity to plus infinity, and you want to sketch this. How does this graph look? And for this, we need to know what is the, let me use the black color for this. So if this 6 was missing, then the logarithm of, let's see, if it is just a logarithm of x, and remember there is a g, but the base is not shown, it is tan x right here. And let's see, this is tan, and this is the function. So 10 is quite a big number, so the graph will be it is already like this. See? This will be the graph of, it goes to x-intercept that we have seen is 1 comma 0. This is how it goes down like this. This is the original graph. Now what's happening is there is that 6 here. What does this 6 do then? So you have to remember that when you have f of x and the new function gx is, let's see, x is f of x over c. Now this c behaves like, if c is, if, if this c if this c if this c is greater than 1, if c greater than 1, then there is a horizontal stretch by scale factor of c. So that means if you see this part, now in this case they give us 6. So this 6 is bigger than 1. So because it is bigger than 1, so because it is bigger than 1, so based on this 6 which is greater than 1, at any point, let's see if there is a point here. If there is a point, let's say this point, this gets the x, so if it is x and y, the x gets multiplied by scale factor of this 6. So this, it will go, whatever is the number, whatever this number will go multiplies by 6 here. It means maybe here. So that's how the graph, and this graph will get stretched, and onto the left side, this side, if it is a smaller number, let's see if it is x was 0.8, and if you multiply by 6, it becomes, so that x will get multiplied too. We don't even have to take this 0.8. We can even think of this itself. Let me take this off. Example, we'll take this point. This point in the beginning is, this is 6 comma 0, right? And because there's a scale factor of 6, so 6. So this 1 comma 0, this is 1 comma 0. You multiply 6 to the 1, this one, it becomes, so if this is 1, 2, 3, 4, 5, 6. So that's where there is a horizontal stretch by scale factor of 6. So the graph goes this way. That's how the graph will go. And this will still go down to the vertical asymptote will remain the same, but this is how it will get stretched. And I hope you can figure out yourself from whatever the information is provided here. The main thing is, can you figure out that this became too much confusion here. Let's see if I can make it nice. So the actual original graph of logarithm of x to the mm, to the base 10, this is the original graph, but then because of the 6, and you can see check also when is this going to be 0, you just put x, this is equal to 1, because that's the only way logarithm of 1 is 0. No matter what the base is, it's always 0. So you put this equal to 1 and multiply 6 both sides, and you get x equals 6. And that's why this point shifts here. Not shift, it's multiplied. It's like by scale factor of 1. So whatever is x and y, now it is kx or cx. If whatever that c is here, now in this case c is 6 here, so it goes right here. I hope that helps. So in this video, I completed, what are the problems I completed is 4.2, 4.3. I try to do a lot of practice problem. Maybe in this I did 4, 5, 6, 7, 8, 9, 10. And the next video which I'll do tomorrow, I'll do 11, 12, more problem, almost like I think 5 more problems, 5, 6. And kindly just, if you ask me question in the class, if you get confused at how to go about. And I hope this videos will help you to finish your Cengage different situation homework problem. And not only that, and then after 4.1, 4.2, 4.3, and 4.4, you have quiz number 8, and I hope you do that also. And see you then. Let's continue in the next class.